All right, we are Trig Unit 3, Day 4, Area of Triangles. So we're going to find area of triangles based on the law of sines, and we're going to find the area of triangle based on the semi-perimeter. And maybe the word semi gives you an idea what semi-perimeter is. All right, this is essentially how this formula gets derived. If sine of this angle is opposite over hypotenuse, it's going to be sine of A is going to be h over b. If I multiply both sides by b, I find that your height is equal to b times the sine of A. So that's what we have here. So the area of the triangle is 1/2 base times height. Our base is c. Our height in this case is going to be b sine A. So the area becomes 1/2 cb sine of A. I could do the same derivation using any of these angles, and depending on the angle, what you'll notice is my angle that I'm using is, and this does not, the two sides that I'm using for this formula does not include the side opposite the angle I'm using. So if we're using angle B, it's going to be 1/2 AC sine B. If we're using angle C, it's going to be 1/2 AB times the sine of C. So the side opposite the angle is not in this formula. So basically, this is the generic version. The area of the triangle is 1/2 side sine of included angle. So you can see here, in this case, A is here, and the two sides that we have are B and C. A is in between them, so A is the included angle. So that's the first formula for area of triangle based on the law, based on sine. Not really even the law of sines, just sine. All right, example, find area of ABC. So it's a side angle side, so we have two sides in the included angle, so we can basically just plug it into the formula. It's going to be 1/2 12 times 18 times the sine of 94. Pretty simple, and you're going to end up with 107.73 units squared. I don't have units in this case, but if I do, you should make sure, since it's an area, they're squared units. Sometimes you don't have side angle side, so here's one you have angle side angle. We're going to have to use the law of sines here to get our another side length so we can use this formula. And let's see, which it doesn't matter. I guess actually I want to find this one. Actually, or I could find this one. It doesn't matter. Either way, I'm going to have two sides in the included angle. So which one did I decide to use? Sine of 28. So I'm looking for side C. I don't have this very well labeled here, do I? So this must be C is equal to, so this has to be sine, well, this is 180 minus 117 minus 28, which is 35. So I have this being 35. And so side C has to be, I guess I'm sorry, I don't have this very well worked out. I kind of combined all the steps here. So it's going to be C over the sine of 35. So that means that this is, that doesn't make sense either. All right, I think I've recovered from that. I had grouped this all together, but the way this is how the triangle should be labeled. So I found side B by subtracting 117 and 28 from 180, so it's 35 degrees, or sorry, angle B. So angle B is 35 degrees. So I know, and this is the side across from angle B, so this is side B. So 22 times the sine of 35 has to equal C times the sine of sine C, angle C, which is 28. Cross multiply, and I'm going to get 22 sine of 28 is equal to, and I've written too big up here. Let me do it over here. So when I cross multiply, I get 22 times the sine of 28 equals c times the sine of 35. And now I divide both sides by sine of 35 to solve for c. And that's where this comes from. And then when I plug that in, I get c is equal to 18. So let me get rid of all of that. C is 18, and now I can use my 1/2 BC sine of A. So this is obviously my A. But you have multiple options. I could find actually side A if I wanted to using law of sines, and use this as my included angle. So since I basically knew all three angles, it's up to you for which side you'd want to solve for and use in your area formula. So 1/2 22, 18 times the sine of 117 gives me an area of 176.4. All right, so what happens if we don't have any angles, if we just have side, side, side? Well, it turns out we can find the area of the triangle anyway. So first of all, it involves a semi-perimeter, which is S. So S stands for semi-perimeter in this case. What's a semi-perimeter? Well, semicircle, I don't know what else you use semi for, but it stands for half. So it's 1/2 the perimeter, and remember, perimeter is just the length of all the sides added together. So in this case, with the triangles and the sides are ABC, it's going to be 1/2 A plus B plus C. So there's a formula developed using the semi-perimeter that will give you the area of the circle. And here it is. It's the square root of the semi-perimeter times the semi-perimeter minus the length of A times the semi-perimeter minus the length of B times the semi-perimeter minus the length of C. So there's a lot of multiplication going on, but it's a pretty straightforward formula. So let's look at it. Here's our triangle. What's our semi-perimeter? Well, I add my sides, 52, 25, 63, which is 140, and then multiply by 1/2 or divide by 2, and I get a semi-perimeter of 70. And now I plug it into Heron's formula. The square root of my semi-perimeter times my semi-perimeter minus side A, which is 52, and it doesn't matter which you say is side A, B, or C, it's going to work out the same anyway, times semi-perimeter minus side B, times the semi-perimeter minus side C. And I find if people put this in the calculator one big on one line, there tends to be things that go wrong. So you might want to break this down into steps, especially on a test. Show me what you get at each step. So this is going to be 70 times 18 times 45 times 7, which I don't know what it is, but if you take the square root of that, you're going to get 630. Don't forget to take the square root. Not anything really complicated, just some intense calculations there. All right, area of parallelogram. So just like we looked at parallelograms a couple sections ago, parallelograms are two triangles. So if we find the area of one of the triangles, they're two congruent triangles, because remember, the opposite sides are congruent. And so this triangle is going to be the same or congruent to this triangle. So we can use, for this one, we can use our sine formula. It's going to be 1/2 side times the sine of the included angle. And that's going to give us 69.3. So that's the area of the triangle. We're going to multiply that by 2 to get the area of the parallelogram. And if you're really clever, you see that we have a 1/2 here, so we cut this in half, and then we end up multiplying it by 2. So you can actually find the area of the parallelogram by just eliminating the 1/2 in this formula. So it's just going to be BC sine of A without the 1/2. If that is confusing to you, then just go ahead and use your area of the triangle formula and multiply the result by 2. Either way, you're going to get 138.6. All right, so this is a triangle for you to find, parallelogram for you to find the area. You should check your answer in class on this. And then the worksheet is your homework. Bring your questions to class.